The Webb Telescope is going to search for any signs of life way out there. This month will mark the beginning of a new chapter in the quest for extraterrestrial life, as the most powerful space telescope that has ever been constructed will begin spying on planets that orbit other stars at the beginning of this month. Astronomers are keeping their fingers crossed that the James Webb Space Telescope will be able to shed light on whether or not any of those planets have atmospheres that could potentially support life. Hey intellectuals, welcome back to the future space. Today's video is going to be really informative, so make sure to watch the video till the end, because we are going to reveal some secret data about Jupiter. But before we begin, make sure you subscribe to our channel and click the bell icon so you don't miss any of our amazing videos. The discovery of an atmosphere in a system other than our own would be significant in and of itself. However, there is a possibility, albeit an extremely remote one, that one of these atmospheres would provide what is known as a biosignature, which is essentially a signal that life itself is present. I think we will be able to find planets that we think are intriguing, good chances for life, said Megan Mansfield, an astronomer at the University of Arizona. I think we will be able to find planets that we think are interesting, said Megan Mansfield. But it's not at all certain that we'll be able to recognize life so quickly. To this day, it is believed that there is only life on one other planet in the entire cosmos, and that world is Earth. Although scientists have been sending probes to Mars for almost 60 years, they have not yet discovered any evidence of Martians. On the other hand, it is not completely out of the question that life is concealed beneath the surface of Mars, or that it is sitting dormant on one of Jupiter or Saturn's moons. Even though Venus's atmosphere is composed of clouds of sulfur dioxide and is extremely hot, some scientists have not given up hope that the planet could harbor life. Even if it turns out that Earth is the only planet in our solar system that can support life, the cosmos is filled with so-called exoplanets, which can be found in many other solar systems. 1995 was the year that Swiss astronomers discovered the first exoplanet that orbited a star similar to the Sun. The exoplanet, which was given the name 51 Pegasi b, was discovered to be a puffy gas giant that was larger than Jupiter and was a warm 1800 degrees Fahrenheit. It was not a promising habitat for life. Since then, researchers have identified over 5,000 more planets that exist outside our solar system as exoplanets. Some of them are far more similar to Earth than other planets, having nearly the same size, being built of rock rather than gas, and circling in a Goldilocks zone around their star, which means that they are not so close as to get roasted, nor are they so far as to get frozen. Unfortunately, owing to the fact that these exoplanets are on the smaller side, research on them has been exceedingly challenging up until this point. This will soon change, thanks to the James Webb Space Telescope, which was introduced into space around the same time as last year's holiday season. This telescope will function like a magnifying glass, enabling scientists to examine these worlds in more detail. Following its departure from Kourou in French Guiana, where it was launched, the telescope has now entered its own orbit around the Sun, having traveled a distance of 1 million miles from Earth. There, a shield guards the 21-foot mirror, preventing any heat or light from the Sun or the Earth from reaching it. In this extreme darkness, the telescope is able to pick up on minuscule glimmers of light that are extremely far away. Some of these glimmers of light have the potential to disclose new information about planets that are very far away. According to Dr. Mansfield, the Space Telescope is the first large space observatory to take into account the research of exoplanet atmospheres in its design. Midway through the month of June, NASA engineers started photographing a variety of objects with the Webb Telescope, and on July 12 they will make the first images obtained with the telescope available to the general public. According to Eric Smith, who is the chief scientist for the program, the initial batch of images will include extrasolar planets. Dr. Smith deemed these photographs to be a quick and dirty look at the power of the telescope, because the telescope will only spend a very small amount of time examining the exoplanets. These brief glimpses will be followed by a series of considerably longer observations beginning in July, which will yield a significantly sharper picture of the extrasolar planets. Observations of the 7 planets that revolve around the star known as TRAPPIST-1 are going to be carried out by multiple groups of astronomers. Based on earlier findings, it appears that 3 of the planets are located within the habitable zone. As a result of TRAPPIST-1's small size and low surface temperature, the star's habitable zone is situated much closer to the star than it is in our own solar system. As a consequence of this, its planets with the potential to support life orbit the star at a relatively near distance, and it takes them only a few days to complete one full round. When the planets come into view of TRAPPIST-1, astronomers will have the opportunity to investigate a fundamental but essential question: Does any of the planetary bodies have an atmosphere? According to Nicole Lewis, an astronomer at Cornell University, if it doesn't contain air, it's not habitable, even if it's in the habitable zone. Astronomers like Dr. Lewis and others would not be surprised if the planets in the TRAPPIST-1 system did not have atmospheres encircling them. Even if the planets had atmospheres when they first formed, the star may have removed them a very long time ago by radiating them with ultraviolet and X-ray light. According to Dr. Mansfield, it's plausible that they could just strip away all of the atmospheres of a planet before it even had a chance to start producing life, and this might happen very quickly. That is the first-order question that we are seeking to address here, whether these planets might have an atmosphere long enough that they would be able to create life. When a planet passes in front of TRAPPIST-1, it will cast a very small shadow. However, the shadow will be too small for the space telescope to photograph. Instead, the telescope will pick up on a very little dimming in the light that is going from the star. Life recognition. Of course, it's possible that life on exoplanets won't have any similarities to life on Earth at all. Even life on Earth, such as extremophile species, might appear foreign at times. This is a type of organism, usually bacteria, that lives in extremely severe settings where other living organisms cannot survive. Some can survive in temperatures as high as 250 degrees Fahrenheit. Others can withstand temperatures as low as -4 degrees Fahrenheit. Some live in strong acids with pH levels below 3, while others live in areas where we would not expect to find life at all. However, it may be more prudent to begin looking for Earth-like planets where life is more likely, rather than planets with temperatures of 250 degrees Fahrenheit or that are soaked in acid. Prime candidates may have temperatures high enough for liquid water to occur on the surface and be orbiting a steady star. Our Sun is classified as a yellow G-type star. However, these stars are typically short-lived and uncommon in space. Planets in orbit around the more abundant red dwarf stars, which are slightly colder and less bright than our Sun, may be a more likely subject of study. Because these stars have significantly longer lifetimes, there is more time for life to begin and for evolution to evolve complex life forms. The initial goal. The initial project for JWST is to investigate the TRAPPIST-1 planetary system, which is 40 light-years away from us. This system is made up of 7 rocky Earth-sized planets around a cold red dwarf star. 3 of the rocky planets are in the habitable zone, which indicates liquid water might exist on their surfaces. The TRAPPIST-1 star is only 1/10 the mass of our Sun and much cooler, but the planets orbit close to it and get light levels comparable to those of Earth. One of the most fundamental problems in science is whether there is life someplace else in the universe. Perhaps the universe is teeming with life, or perhaps we are completely alone, marooned on a lonely world in the immensity of space. In either case, the precise solution will almost certainly necessitate substantial psychological and philosophical alterations for humanity. Alright folks, that's pretty much it for this video. Hope you find it helpful. If you enjoyed this video, then make sure you subscribe to our channel and hit the notification bell so that you will never miss any updates. Till then, you can also check out our other videos as well, and we will see you in the next one.